Okay, problem number 1, function or not a function? You think it's a function?
Yeah.
What can we do to tell if it's a function or not?
Graph it.
We can graph it, right? So I'm going to go to my TI84, you have a TI-nspire. Does everybody know how to get to the graph icon on their Inspire?
I'm using them calculators.
Well, my TI84, if I go to second, this, and I go x
It is a function.
minus 4.
It's a function we can graph it.
Well, yeah, you graph it, and also,
It is a graph.
does this pass the vertical line test?
Yes.
Yeah, the graph does pass the vertical line test, so yes, this is a function. Let's go on to the next problem. Yes, camera's running. Function or not a function?
Wouldn't you have to make it y equals first?
There ain't no function.
Oh, who said y equals first? Very good. Miss Hutchinson, you got a question? Okay. Yes, Mr. Ortega, let's do that. That's a very good suggestion. Okay, we're going to go ahead. What do we have to do to get in y equals? Can we put it in y equals right now? No, what do we have to do first?
Convert it into
Turn into y, right? So let's go ahead and turn into y. So we have 2y squared equals x. I switched it around because I want to solve for my variable on the left side, right? How do we go ahead and solve for y? Which 2, Mr. Burns?
Divide by 2.
Very good, Mr. Porter, Mr. Burns, excellent.
Since this
Excellent, okay. What happens to the left here?
this is a square, don't you got to get the, what you call square root?
Ah, beautiful, Mr. Ortega, very nice. Okay, we got this. Okay, square root, right? So we take the square root of
flat.
both sides, right?
Yeah.
But what happens, so we're going to have y equals, what happens when we take the square root of something? Well, we're going to have a plus square root of x over 2, and also we're going to have y equals negative square root of x over 2. Now, is that a function?
No, because they're going to have...
Well, it's 2 functions, right? So we're going to have, we could plot this in our calculator, but it's going to come up something, if we graph it, it's going to come up something like this. X over, it's going to be like this, and it's going to be like this. So is that going to be a function? No. So therefore, answer to this is not a function. All right?
So basically all the ones that have the y being squared, they're not functions.
Yeah, because you'll have to take a square root to solve it.
Yeah,
Exactly.
because they're going to repeat top and bottom.
Yeah, because there'll be a top. Same thing with the equation of a circle, or an ellipse, or a hyperbola. Same reason, not a function. All right, you guys seem like you're paying attention, catching on. Very nice. Yes. Yes, go ahead. Okay, problem. Okay, this one here, function or not a function?
Function.
That's a function. It's not repeating.
Okay, so you call it a function because
It's not repeating.
vertical line test, right? I think that is a function. All right. We'll go on to problem 7.
Hey, you moving fast, right?
Not a function. Why is it not a function? Okay, fails vertical line test. Not a function. Number 7. Okay, find the domain. Problem 9. Find the domain of this function. Before we graph it, algebraically, can we figure out what the domain is of this?
What? You forgot the domain.
Cool.
What did Mr. Ortega, what did you say?
Wait, no.
You don't know.
So we answer the question, we just put not a function or a function.
Well, that was for number 7. Here, we're trying to, for number 9, we're trying to find the domain of
So we
this.
find, okay, so domain, okay.
Yeah,
Thank you.
number 9. So we're getting into a new set of problems, essentially.
Okay, so for like 2 to 4.
Now, domain means they're allowable input values, right? What can you do to, if you don't know it algebraically, what can you do? We can graph it, right? Mr.
And then look at the table.
Yes, very good. Okay, Mr. Ortega said, look at the table.
Is it a different way to do this?
Easier way than graph it?
No, I'm saying, like, this is an easier way to grab it.
Yeah, this is easy. Well, one way you could look at it is logically. Is there any number, can you input any value for x in there? Can you put any number for x in there?
Yeah.
Yeah. So if you can put any value for x in there, really the domain is going to be all real numbers. And if you know your characteristics of quadratic functions, you'll know that that is going to be, or any quadratic function, you'll know that that has no restrictions to the domain. So it would be all real numbers.
Yeah.
But if I go +4 here, and as Mr. Ortega says, we can go take a look at our, I have it set up as going up and down by 1/2, but you can see that it goes to so I don't see any restrictions at all to the domain. It goes down to 4 and goes up. So this will be all real numbers, or in interval notation. How would you write this in interval notation? Domain is what? How would you write this in interval notation? Since we
I knew it. Oh, interval will be
Is it infinity?
parentheses,
Infinity?
negative infinity,
and then comma,
comma,
infinity,
positive infinity.
and then close.
There we go. So that's going to be interval notation. All right? Find the domain. Any questions on this? Okay, we're going to go to the next one, 11.
Oh, you mean 10?
You need 11?
You
Okay.
missed number 10?
Yeah, we're just doing the odd ones here. Your homework is number 10 and 12. All right? Now this one here, can we have any restrictions? Are there any restrictions to the domain here?
Yes.
Is there any number that the domain cannot be?
Yes.
Which one?
The one at it can't be -3. No, wait. It can't be 3 and -1. Wait, how does that go here? Or is
Okay,
it-
the way we do to find the restrictions is we set each one of these factors equal to 0.
Yeah.
So if we have x plus 3 equals 0, that will tell us a restriction. And if we have x minus 1 equals 0, that will tell us another restriction. So what are our restrictions here? Okay, Master Castaneda says subtract 3. So we have x equals -3. Well, now, the thing about it is, it's not that x equals 3, it's really what x cannot be. So that would be a restriction for the domain. Okay, what about over here on this other one?
Dang.
Positive 1? Because if we add 1,
That's not that's...
add 1, and then we have x equals 1, which is again what it cannot equal.
Yeah, see, I knew it was -3 and 1.
Yeah. So I want to show you in the graphing calculator now. I'm going to put it in here, and it's going to be easier for you on your calculator than it is on mine. But I'm going to go and put it here. I have in the open parentheses 3x minus 1 and divided by, and I'm going to have to put double parentheses to get it right on my calculator. On yours, when you graph it on your Inspire, you can just put it under a division bar. Does everybody know how to graph this on your Inspire? You go to the graph icon at the bottom, and then you press the little thing here, right, to make it a fraction, and then you put this on top of the fraction and this here on the bottom. So you have to put these two binomials in parentheses below. But if we go ahead and we can go ahead and look at first by graphing, and if we graph it, this is what it looks like. And what we have is we have a discontinuity or break right here at -3, and also here at 1. So does this back up what we saw here earlier? Yes, it does. Where can we go further to back up? What view can we go to? Go to the table view. Now in your Inspire, you press Menu, and then you're going to see View, which is 2, and then go down to Show Table.
Or you can just press Control T.
Pardon me? Control T?
Yeah.
Or Control T. Very good. Some advanced calculator skills here by Mr. Ortega.
Oh yeah. Oh
You
yeah.
learned that last year. Thank you very much.
But I'm going to change my window here because my table set because I'm going up by 0.5. I'm going to go up by 1. So if we go here, we see we see an error at x equals 1, right? Just like we had it earlier, right?
And undefined.
And then also at -3. So now we're going to go on interval notation, how to write this. We're going to do something a little bit different in writing. I want you to pay attention. We see it can't be here at -3, but can be values less. So what we're going to do is divide into 3 parts. We have from -infinity, greater than -infinity, but less
But
than
less than -3.
-3. Okay, and then we have this one here between -3, but not greater than -3, but less than 1. And then finally we have between 1 and positive infinity, less than positive infinity. And to put them all together in interval notation, we put a U, a big U between them. What does this big U mean between them? No, it's not undefined. What does the big U between them mean? It's an interval notation way of saying union. The big U means union. So that means this and this and this. So if you get used to seeing that and writing it, it's going to help you. Any questions on number 11? Okay, let's go to number 13. Okay, number 13.
Hey, this going on YouTube?
Yeah, I hope to put it up there tonight.
Hey, can we get a shout out right quick?
Maybe now. Find the domain of this. Now, again, how would we work out what the domain is of this guy? What are the restrictions to this domain? What can the denominator not equal?
Oh, it can't equal negative positive 5.
This whole denominator cannot equal what? Cannot equal 0. Mr. Castaneda says 0. Okay, so if you get that in your mind, so you're trying to find out the values where this denominator equals 0. Now, how would we go ahead and figure that out? What can we do here? What technique can we use here of these 3 over here on the right side? Okay, well, difference of squares does not apply, right? You don't. Gray's common factor. Who said Gray's common factor? Very good. Very nice. Mr. Porter, very nice. Okay, how do we go ahead and factor out, take out the Gray's? What's Gray's common factor here?
5.
No, it's not. 5 is a factor of this.
It's 1.
Well, 1 is not the greatest common factor because it's 1. There's a greater common factor
X,
than
X,
1.
X, X.
Okay, Mr. Ortega says X. Anybody else? Mr. Ortega says X. Okay, so let's try X. So when we factor out X, what do we have left?
X squared is 2.
What do we have, Mr. Castaneda? X and
5. My 5.
X and Mr. Ramirez, Mr. Bryant. What do we have left? -5. So we set it up, we have X equals 0, right? And then over here, we separate out to X minus 5 equals 0. So this one here, we already know it can't be that, right? What about this over here? Mr. Racinos, what do we have here? We got x minus 5 equals 0.
You got 5.
Okay, very good, Mr. Racino.
Equals x equals 5.
So we know that it can't, actually it cannot be that, right? So now we can write it as from negative infinity, comma, 0, union, 0, comma, what?
Infinity.
No?
No, 0,5.
0, comma 5, union here, and then 5, comma, positive infinity. So that's going to be it. And if you graph it in your graphing calculator, you'll see the same thing we saw earlier. So that's going to be our answer algebraically.
Okay, go to you.
It's a U. It's a big U. It means union in interval notation. All right? Okay, next. Okay, find the domain of this. Again. Again, find the domain. You're going to have, it's wherever this is equal to 0. So if you have x plus 1 equals 0, or x plus 1 equals 0, yes. Well, we're going to be out in 5 minutes. Okay, now, so x minus plus 1 equals 0. How do we solve for x here?
Get rid of that 1.
Okay, very good. So x equals negative 1, which means it cannot be that. Now, can we solve for 0, x squared plus 1 equals 0? Can we solve for that there?
Yeah, you can.
Okay, x squared plus 1 equals 0. Well, if we subtract 1, we have x squared equals negative 1. If we take the square root, can we take the square root of a negative number here? Not with real numbers. So we say that that is not a. So that's a restriction. Is there a restriction up here? Okay, square root of 4 minus x. What is x? What can this be a negative? Can inside here, can that be a negative number?
No.
No. So we have, it has to be greater. So what's going to be the possible values of x?
0.
Okay, 0 could be a possible. What else? You can have it be 4 or less, right? It can be 4, 3, 2, 1, 0, negative 1. So we're going to say our maximum value here
4.
is going to be 4. So 4 is going to be over here in our interval notation, and we're going down to negative 1, right? And that's going to be like this, and then we're going to have union negative infinity, comma, to negative 1. So I think that's all of it here. And if you graph it, you're going to see the same thing. I hope. Okay, if we graph it,
You lost me.
pardon me? Okay, well let's graph it. Maybe you won't be lost when you graph it. Okay, we're going to go ahead and take second. Okay, 4 minus x. And that's a good point. Some of these solutions here are not going to be as apparent to you at first. Okay, we have x plus 1. Again, this is easier for you and your inspire than it is for me. Then x squared plus 1. Yes. Well, we have only 5 minutes of class left.
Okay.
Okay, then we graph it.
I ain't saying nothing to answer this question or not, boy. He said that it's on my spot.
And we don't see it. We don't see it real well here, but we see this break at negative 1, right?
Yeah.
We see this break at negative 1, so that corresponds with this here, right?
Yeah.
From negative infinity to negative 1, that corresponds. But on the right side, we can't see it that well. So what view do we go to?
Left side.
Let's go to the table view. Okay, and we see that error at -1, right? But then we go up here and see we have 4, right? But what happens after 4? Okay, we have an error. So that's going to be our maximum value is 4. So we have this interval here between -infinity and -1 by union of between -1, greater than -1, but less than or equal to 4. So that corresponds. Okay, the next two ones are range problems, 17 and... Okay, find the range. What's the range of this going to be? Okay, 10 is going to be part of the range, right? What else?
That's it, 10.
Okay, you can have it be 10. The range. One thing you can do is you can look in your graphing calculator, and for you, you're going to have to, if you graph it, you take a good look at it. Here we go ahead and put in 10 minus x squared. Okay, if we graph it, we see this thing here. Okay, what's going to be our maximum value here? 10. What's our minimum value? -10. But what's happening down here? Is this stopping right here? Negative. Who said -infinity? Very good. Okay, very good. Okay? 20. All right, very good. So we're going to have, we'll say that our range is going to be, okay, it's going to go all the way up to 10, right? So we're going to go from -infinity, comma, 10, close brackets. So that's going to be interval notation for our range of this relation. What's the domain of this? The domain is all real numbers. Okay? -infinity, +infinity. Okay.
So it'll be parentheses, -infinity, comma.
Yeah, comma, +infinity. Okay, find the range. Where's that other one? Oh, here it is, okay? X squared. What I'm going to do, this is find the range of this one, 19. So I'm going to take x squared divided by parentheses 1 minus x. And this is harder to see because you can't see the error on range, but we're going to take a look at it. I don't know why it's not showing up. Squared 1 minus x. I'm not seeing it somehow here. Okay, 19. Okay, -1 should not be part of the deal. So it should be, there should be an asymptote, a horizontal asymptote at -1, but I don't see it here. But anyway, we're going, oops, I left this up here. We're just going to leave it here today. I have some questions about this last one. I hope you get an idea. I'm going to have this video up here probably this evening, so you can repeat that, get a hold of me, come in before school, talk to me about these things. The even number problems are going to be similar to the odd number problems we went over today. So let's get ready.